Good morning, everybody. Today we're going to be talking about parabolas and in the context of conic sections. And these are going to be written a little bit differently, and they're not going to be quite functions. Half of them aren't. So we're going to be talking about that as well as new terminology behind it and why it's helpful for us. But we are going straight into it. So there are four types of parabolas. Basically, which way does it open? And these are all in a vertex form where you have the vertex given to you HK. In Careful, they are written differently than we're used to seeing. Normally, we would see all of the extra stuff attached to the thing being squared. This is not the same case. So based off of this, whatever's being squared implies the direction it's going to be opening, or it's either going to be vertical or horizontal based off of what's being squared. If x is being squared, it's either going to be vertical opening up or vertical opening down. And in this case, these are placed correctly, as you might have guessed. But both of these have a vertex of HK. Ideally, you would have them a little bit at the same spot. But the way you can tell if it's opening up or down is this negative coefficient. That -4 tells you that it's going to be pointed down, where +4, A, is going to be pointed up. And A is always positive if you're doing these, if you're writing it this way. But we'll get into what A is in a second, but it's an important part within graphing these and finding what's known as the focus. Y is being squared, so when Y is squared, it either opens to the right, or has that dent in the right, or it opens to the left. And again, it depends on either positive or negative. Positive, when we're talking horizontal, is to the right, so it should be opening to the right. Negative, when we're talking horizontally, is to the left, so again, it should be opening to the left when we're doing it with the negatives. But still, HK are our vertices, or it is the vertex in both of these. It's still weird, and it throws me off whenever we start talking about it and using this form. But the 4A, again, is not attached to the squared portion. So the part, I always look to see what's squared, and then is the coefficient attached to that or the other thing. If it's not attached to that, then I need to move it around to find the useful information. All right, the vertex and the focus. The focus has some cool things along with it. I'll attach a video that kind of talks about what the focus does and all these things. But for the sake of today, for the sake of brevity or just shortening the videos, just know that the focus is an important part of the graph. And same thing with the directrix and the latus rectum. So the latus rectum, definitely a very serious term. Don't laugh at all at the word latus rectum. Yeah, I don't know why that would be funny, but I've heard Snickers before, and I don't think they're going to stop for some reason. Latus rectum, okay. But wait, sorry. There's some important stuff there. The distance from the vertex to the focus is A. The distance from the vertex to the directrix is also A. The focus is a point inside of the curve, so it would be here. And then the directrix is a line on the other side of it going kind of parallel with the graph. That's a very big air quotes, kind of. But basically, it's the distance from A and then A again. So if you're going vertically down and then going horizontal or vertical, like this would be, just to squeeze it in there, this would be our directrix as well. And those are just helpful, again, important information that I'll post in a separate video on why those things are important at all. But they're kind of cool, so if you are interested, check it out. Now, the latus rectum is a line segment that connects 2 points that are 2A away from the focus. So this is 2A and this is 2A. The lattice rectum would be 4A away from each other, or those two coordinates. And when we're graphing today, we're just going to be focusing on those major points. We're not going to plug anything else in except for those. So based off the vertex, the directrix, the focus, and the lattice rectum, we're going to have 5 features that we're going to be graphing and basing the rest of the graph off of that. So moving into it, we can find the equation of the parabola and also graph by hand. So we have a vertex is 0, 0. And if we look at our forms, our focus is 3, 0. I'm going to graph both of those first. So 0, 0. I'm going to use blue. So 0, 0. Directrix is 3, 0. And that tells us a few things. One, it tells us the distance. So A is equal to 3. That's important. The other thing is it tells us which direction it opens up. The parabola has to open up to basically trap the focus. So the fact that the focus is to the right, our graph is going to open to the right. Okay, so it's going to look like this. That helps us decide which of the 4 forms we can use. Since it's opening to the right, we're using y minus k squared equals 4ax minus h. Okay? And we know what a is. So I'm going to get rid of the sloppy graph and put in the correct graph. But since a is 3, we can also figure out what the lattice rectum is. The lattice rectum is 2a. The segments are created by making 2a away from the focus. 2a would be 6. So I need to move 6 up and 6 down. 1, 2, I can just count that. So there and there. These are enough points to make your graph, so you need to basically connect them, try to do it as neatly as possible. Not super possible for me with the computer, so sorry if it's a little sloppy, but you're just using those coordinates. It doesn't ask you to find the directrix, but the directrix would be 3 or a away from the vertex, and it's a vertical line running air quotes parallel to this parabola. Okay, so there's the graph. We need to make the equation, but we have all the information we need. So h is 0, k is 0, so we're going to have y squared equals 4 times a times x minus 0. So y squared is equal to 12x. Unfortunately, there's no quick way of writing this or graphing this. There's no mode in the mode section to do this, but you can still solve for y and plug it into the function section or function mode. Yes, going back to functions and doing that way. Okay, moving on. So the focus is negative 4, 4. I'm going to plot that, negative 4, 4. The directrix is 2. And we go from there. Okay, so what do we know? We know that A is the distance from is the same distance from the focus as it is from the directrix. So that means halfway between. A is the distance from the vertex to the focus, and it's the distance from the directrix, meaning that the vertex is halfway between these two things, and it's perpendicular to the directrix. So it's along this line. We know it's going to be opening this way because the directrix or the vertex basically protects the focus from the directrix. But we're going to split it, and right down the middle, halfway between this coordinate and this coordinate, would be right here. So the vertex is going to be negative 1, 4. And you could have done that by averaging the x coordinates as well, but that's enough. So from there, we can say that the a value should be 3 because it's 3 away from both. Also, half of 2a would give you the a value. But 2a is 6 again, so we're just going to move 6 up, 6 down, and to get our latus rectum out of this. So we're going to plot that point, and plot that point, and again, make our very nice parabola using the idea of the latus rectum. Okay. This is again sloppy, but that kind of looks like the vertex. That's not technically the vertex. I'm going to correct that a little bit. Definitely made it better. Okay. Directrix needs to get fixed. Okay. Cool. Done with that. All right. Find the vertex focus in directrix of the parabola x minus 3. Oh, we didn't. Sorry. Whew. Okay. Putting it back into it. It's opening to the left. That means that we need to work with the other version of this. Basically, we're going to have negative 4a x minus h. And now we don't have 0 as our hk. So k is 4. Negative 4 times 3 times x minus negative 1. And I am fine if you leave it like this. It's in vertex form, so you want to be able to see the vertex clearly from this. You do want to multiply this out because it would be awkward to see 4, 3. But when you're backwards mapping, you need to divide this by 4 to figure out your a value. So a little extra step involved. Speaking of that, we're going to move into this, where we need to come up with the vertex, focus, and directrix of the parabola, given the equation. So this is negative 4a. A is always positive. I'm going to jump right there first. So a should be 2. A is always positive. So if you're getting a negative value, you're not using the correct version of the equation. This is x minus h squared equals negative 4ay minus k. So we're subtracting 3. Our vertex is going to be 3, negative 1. Our focus is 2 away, 2 away, but in which direction? So we need to figure out which direction it's opening. And we have a negative 4. We have a negative value being multiplied. So it's either opening to the left or down, but x is being squared, so that means that we're moving vertically, essentially. So we're looking at like this. The focus should be 2 down from the vertex. 2 down from negative 1 would be negative 3. So 3, negative 3 is our focus. And the directrix is the opposite direction. So it's above the vertex in this case. And it's a line. So y, because it's horizontal, y is equal to negative 1 plus 2 is positive 1. Okay. Next, we need to rewrite this so that it's in vertex form. So to do that, we get to do completing the square. Get used to completing the square. It's coming up, and it is super helpful, so just get used to it. But all of our standard forms of conic sections are going to be having completed squares because it makes it much easier to graph. Completed squares are just basically graphing form. To identify this, you need to figure out what is being squared, and x is being squared. So I'm going to move everything away from the x's. 4y minus 1. And next I need to actually complete the square. So to complete the square, you're going to take half of b. This is actually 6, but half of b, square it, and add that number to both sides. So half of 6 is 3, 3 squared is 9. You're going to add 9 to both sides. Negative 1 plus 9 is 8. And then you're going to factor that, which it should be a square because you just completed a square. Over here, we need to factor out this coefficient. Doesn't matter what it is, but we only have one y inside the parentheses, so we just need to factor out that number, including the constant that's being attached. So 4 times y plus 2. And we have it in the correct form. It doesn't ask this, but the vertex is equal to negative 3, negative 2. The focus, a is 1, because it's 4 times a that gives us this coefficient. The focus is 1 up because it's opening up. So negative 3, negative 1. The directrix is 1 down from this, and it's y equals negative 3. And then you could also come up with the latus rectum based off of this as well. Okay. Last. Given the parabola, find its equation. So to do this, we need to first identify which equation that we're going to be working with. It's sideways. So y is going to be squared. It's opening to the right, so that means we're going to be using the positive version. So y minus k squared is equal to 4ax minus h. We can figure out hk based off of this coordinate. It gives us hk, so h is negative 2, k is 0. So y squared is equal to 4ax plus 2. To find a, we don't know what this coordinate is. It could be part of the latus rectum. It probably isn't. It just depends on other things. But because we don't know what it is, we just need to plug that in and then solve for a. So we're going to plug in 0 for x, 1 for y. 0 plus 2. So a is equal to, this is 8a, or a is equal to 2 1/8. So we're going to go back and plug it in to this. We get y squared. 4 times 1/8 is 1/2, or 4/8, x plus 2. Again, you can leave it like this. That is cool. Okay. And that's it. So parabolas in a different form, super interesting, and kind of weird that there's other parts to it. Again, I'm going to be posting a video that talks about the directrix, the focus, and it might include the latus rectum in there if I feel like it. But if you want, you can look at that. It's not required at all. But obviously, I'm going to give you some math if I can help it. But I'll see you next time.